So last class we talked about solving our equations and dealing with word problems that we need equations to solve. Today we're going to take the next step into algebra and work with those algebraic numbers a little bit more. We've talked about it briefly, having things like 7x and 4x. And when we add those, just like any other numbers, we must have the same name. And these are both x's. And when we add numbers, we combine the counts. 7 plus 4 is 11. And we keep the same name. So this will just be 11x. The part that most people get crossed up is between this process and the process for multiplying. If that were 7x times 4x, by the way, this is why we use the dot for multiplication instead of the little x, because that could be kind of confusing right now if I had that in there. Well, first of all, we don't need the same name to multiply. We'd be okay multiplying if they were different variables, but in this case they are the same. And when we multiply, similar to addition, we combine the counts, but we're using multiplication now. 7 times 4 is 28. The big difference is we also combine the names. X times x makes x squared, because anything times itself is squared. Because of these rules, you recall, if we had 5x plus 2y, what do we get? Trick question. It's 5x plus 2y. When we add or subtract, we must have the same name. Therefore, we can't do anything with that. But when we multiply, we had 5x times 2y. We don't need the same name to multiply because all we're going to do is combine the counts. 5 times 2 is 10. And then also combine the names. X times y is xy. So we can start looking at somewhat slightly more complicated combinations of these. Something like this. Now you might be looking at it and say, oh, they've got different names. You got x's and y's. But if you look closer, there are some that do have the same name. And we can combine those. So we have 5x here. What can we combine that with? The 3x. 5x and 3x make 8x. Oops, I don't know why I put the x down below. 8x. Then we have 2y and 9y, which makes 11y. This isn't quite complete yet. Whenever we have two digits together like that, we have to link them with something. Just like up here, there's a link between each of the digits. So down here, since this is a positive 11y, we just put a plus there. That is something we run into with these algebraic numbers, is the sign in front of them, the positive or negative or plus or minus in front of them, also translates into a positive or negative. So if we have something like this. This is an 8x. Well, this is not 2x, it is negative 2x. That negative goes with the 2 after it. So 8x and negative 2x would make 6x. And then 3y and 7y is 10y, but we need to make sure we put a plus in there. It's positive 10y. So something like this. Tell me what to do. 3a and 2a make 5a. And then? Yep. Perfect. Negative 7 and positive 3 make negative 4b. And the minus there, the negative and the minus are the same thing. So they're already linked together. We don't need to put a symbol in between them because that negative serves as a minus sign.
As long as there's
some kind of symbol. Yeah. Something to link them together. Well, it can get a little more complex than that. We've already seen, x times x equals x squared. That's the definition of x squared. This then would be what? X to the fifth. That just means 5 x's multiplied together. So with that in mind, what's this going to end up being? X to the fifth. Very good. Because this is 3 x's multiplied together. This is 2 x's multiplied together. And if we're multiplying the whole works together, we have 5 x's multiplied together, or x to the fifth. Basically, all we're doing is when we're multiplying the variables with the exponents, all we have to do is add the powers. So I could have y to the 9th times y to the 13th. That's going to become y to the 22nd. Very good. I'll be careful here. Yep. You're multiplying, but the effect is that the powers get added. You are multiplying them, it looks like the powers are being added together, because you are really taking x to the third times x squared. But the power is just counting how many of those x's are being multiplied together. So the effect or the shortcut is you can just add the powers. Very good question. What if it's x to the third plus x to the second? Well, first of all, there has to be a count there, which is going to be just 1. We don't write it in, but it's there. Can we add those? Well, do they have the same name? Well, you might say, well, they're both x's, but one is x to the third and one is x to the second. If you think of square inches and inches squared, inches cubed, or inches to the third power, they're very different. A square inch is a square that's 1 inch by 1 inch. An inch to the third, or an inch cubed, is a cube that's 1 inch by 1 inch by 1 inch. They're very different. So no, we cannot add those. Even though they're both x's, they have different powers, so therefore they don't have the same name. When we add, we have to have the same variable, but to be the same name, it not only has to be the same variable, it has to have the same power. So to divide, like y to the fifth divided by y squared. Well, y to the fifth is 5 y's multiplied together. Y squared is 2 y's multiplied together. We can cancel out 2 of them and be left with y to the third. Basically, you probably see the shortcut there is you do what with the powers? Subtraction. 5 minus 2 gives us 3. So if I have x to the 19th divided by x to the 11th, I'm going to get x to the 8th. 19 minus 11. Good. So now we can throw some numbers in there with the variables. Does this become 15? 8 and 7? Say no. Why not? Well, we're multiplying, right? We're multiplying, so we don't need the same name. But when we multiply, we combine the counts. Well, when we combine the counts, what operation are we doing here? We're multiplying. Because the counts, the 8 and the 7, are still just numbers. We don't do anything different with them. We still multiply. 8 times 7 is 56. Then we also combine the names. And we are multiplying here as well. X to the 5th times x to the 3rd becomes x to the 8th. Even though the shortcut is to add the powers, we're still multiplying. What we just did here was multiplication, although what we actually calculated was just adding 5 plus 3. I know that's confusing, but it is still multiplication. It's just the shortcut. Remember, you're thinking of it as 5 x's and 3 x's multiplied together. You have 8 x's multiplied together.
You keep saying multiplying, but you're not.
but you are. Even though the effect is it looks like you're just adding numbers, you're not. You are multiplying. It's just the calculation is 5 plus 3 is 8. I know that's really a confusing thing, but remember, here's what you are doing. This down here is what you are doing. That x to the 5th, remember, is just an abbreviation for 5x's being multiplied together. That x to the 3rd is just an abbreviation for 3x's being multiplied together. And if I'm multiplying them all together, now I just have 8x's being multiplied together, or x to the 8th. Does that make any sense?
Not really, but I think if I can just remember it.
Yeah.
Because I'm not going to understand. Does that make sense? I don't understand it.
Yeah, well, stick with it. It's one of those things that it.
You'll remember it. You write
Yeah.
it out.
Yeah, maybe.
It's one of those things that it is very confusing because it looks like you're adding, and when you're calculating it, that's what you do is you add those two numbers, but it is still multiplication, and that's where most people make their mistakes on here. Is they'll look at this and say, oh well, 8 and 7, that's 15 because we're adding. Because when we multiply, we add. No, we're still multiplying, but when we're multiplying variables with powers, the way you multiply them is to add the power.
Multiply it anyway, so you just have to add together how many times you multiply.
That's exactly what it is.
There you go.
Is you're multiplying these together. What you're adding up is how many times you're multiplying them. You're multiplying it 5 times here and 3 times there, so now you're multiplying it a total of 8 times over here. Yeah.
I get it.
So that's better?
Yeah.
So if we have 3 x to the 5th times 13 x to the 12th.
So
39, very good. X to the 17th, wonderful.
Yeah.
This looks a lot more difficult, but it isn't. We start out combining the counts. 4 times 11 is 44. Then we combine each name separately. X to the 3rd and x squared make x to the 5th. We're just adding 3 plus 2. Y to the 13th, right? Y to the 8th, y to the 5th. 8 plus 5 is 13. Now here's a little bit of a tricky one. Z and z to the 3rd. Yeah, there's a little, we don't write it, but there is a power of 1 there. So it's 1 plus 3 is 4, so it's z to the 4th.
Can you leave that there just like?
Yep. Yep. Has an exponent of power, you mean?
Yeah.
Yep. Kind of. In fact, every number has a variable, whether it's written there or not, but we're not quite ready to discuss that yet. I don't want to totally confuse you. Yeah. I'll probably do a good enough job of confusing you before the end of the 2 hours today anyway. So we won't go any further than we have to. So how about this one? What's our first step?
Just the 5 by itself, maybe?
Okay. Where'd the 5 come from?
What's that there?
Oh, right there, yeah. Well, remember, there's a number here. We just don't write it. That's 1. There's,
Because we need something.
yeah, because there needs to be a name there. There's 2 places where we put in 1s. One is in front of a variable if there's no number in front of the variable. The other is the power on the variable. If there's no power there, that's a power of 1. So, yeah, 1 times 5 is 5. Now, x to the 10. 3 plus 7 is 10. Y to the 11. Good. What's in there? So 5x to the 3rd y squared times 7 x squared z to the 5th. Tell me where to start.
Well, 5 times 7 is 35.
So 5 times 7 is 35, yep. Perfect. X to the third times x to the second is x to the fifth.
Y to the sixth.
Well, y to the second. There's no other y in here, so that's just going to stay y to the second. And same with z to the fifth. Just stays z to the fifth. There's nothing to combine them with. Now the question comes up, well, isn't something times 0, 0? If there's no other y there, aren't you multiplying by 0? No, you're not. There. Think of it as being a missing a 1 again, if you want to. Technically, there's no z here, but there is a z there. We just don't write it. We don't see it because we don't need it there. Now I'm going to say this, and this is going to confuse you, so let it go in one ear and out the other. Technically, there's a z to the power of 0 there. Anything to the power of 0 is equal to 1. And I can multiply whatever I want to by 1, and it won't change it, right? Multiplying by 1 doesn't change a number at all.
Yeah.
So I could put in a z to the 0 there. What's 0 plus 5 is 5, so it's just z to the 5. And the same over here. I could put in a y to the 0. Well, 2 plus 0 is 2, so it's just y to the 2. Again, I realize 99% of you that's probably confusing, but we're going to come back. We're going to talk about that more in the next couple of weeks. So I want to expose you to that concept of anything to the power of 0 being 1. And that those powers do play into that. So on this one, looks kind of ugly, but really isn't much different than what we've been doing. Tell me what to do.
4 times 3 times 4.
So 4 times 3 is 12 times 7, 84. Then what? So x squared, x to the 1, yep, x to the third, x to the 6, good. 2 plus 1 is 3, plus 3 is 6.
And then y to the 6.
Still confused, Rochelle?
Yeah.
Yep. Yeah, x to the 2 and x to the 1 is x to the third. And then times x to the third, 3 plus 3 is 6. Y to the 6th, yep, because this is y to the 1, and y to the 5th, and there isn't a y over here, so it's just y to the 6th. Z to the 6th, yeah. Z to the third, z to the third, 3 plus 3 is 6. That's evil, come on now, I'm offended. I'm going to have to go home and cry myself to sleep again tonight.
Okay.
You guys always drive me to that.
The numbers are coming up. I don't, yeah.
It's not 666, it's x to the 6th, y to the 6th, z to the 6th.
Right.
Now whose turn is some faster?
No, ew, no.
Okay, so continuing on. The next step then. Kids. We've already talked a little bit about stuff like this. What do we do there? We're multiplying. And there's two ways we can go about it. Remember, the real way to do this would look something like this. We multiply it out. 5x times negative 7 is negative 35x. 5x times 3x, well, 5 times 3 is 15. X times x is x squared. That's the real way to do it, but we don't usually do it that way because it takes space and time. And the shortcut we've been taught is just to distribute. 5x times 3x is 15x squared. And 5x times negative 7 is a negative 35x. We get the same answer as here, but this one takes less space, a little bit quicker to do. But just keep this one in mind. That's the real process. Just like long multiplying out whole numbers. It's really no different. Just have the variables to keep track of them. So now that we know how to deal with powers a little better, we can deal... Oops, go ahead. Now that we can deal with the powers a little better, we can deal with things like this. So we have 4x to the 5th times 7x to the 3rd. 4 times 7 is 28. X to the 5th times x to the 3rd is x to the 8th. Good. 4x to the 5th times negative 2x. 4 times negative 2. Negative 8. X to the 5th times x. X to the 6th. There you go. What do you think? Better than a sharp stick in the eye? For now. Let's have you guys try one. I'll pause for a second. Let's see how this came out for you. So 9x to the 4th times 7x to the 8th was going to be 9 times 7 is 63. X to the 12. Good. 4 plus 8 is 12. 9x to the 4th times negative 5x to the 5th. 9 times negative 5? Negative 45. X to the 9th. Very good. Well, good question. That always comes up. Why don't we just combine those then and subtract them? Because we can't. Because x to the 12th and x to the 9th are different names. And we can only subtract things that have the same name. We could multiply them with different names, but we can't add or subtract them with different names. That's just, otherwise we could have combined these first before we multiplied. But since it's x to the 8th and x to the 5th, we can't subtract them because they're different names. If they're both x to the 8th, then you could combine them. You can come across something like this. So it's something like this. This is just an order of operations problem. We have parentheses. Can we do anything in the parentheses? Can we add those? Say no. No, we can't. So then the next question, we can't do anything in the parentheses. You get confused, Billy. Because this is x to the 4th and x squared. They're different names. So we can't add them. So we can't do anything in the parentheses. So the next question is, can we do something to the parentheses? And that's being multiplied by the 6x to the 5th. So we're going to multiply that by the 3x to the 4th. 6 times 3 is 18. X to the 9th, yep. Now we have the 6 times the 7x squared. 6 times 7 is 42. X to the 7th. But yes, we still have the negative 13x to the 9th out here, which can combine with 18x to the 9th. 18 and negative 13 makes 5x to the 9th. When we add or subtract, we keep the same name. That's another very common mistake, is a lot of people try to make that x to the 18th. It's not. We're not multiplying anymore. We're adding or subtracting. And, of course, we still have the positive 42x to the 7th. We might have 3y to the 7th minus 5y to the 3rd times 4y to the 6th plus 2y to the 4th minus 7y to the 9th. Now we look at this one, and it looks ugly, and it is a little bit. But, again, it's order of operations. Our eyes should be immediately drawn to the parentheses. Is there anything we can do in the parentheses? No. To the parentheses. Yeah, it's being multiplied right here. But it's not being multiplied by 5y to the 3rd. It's actually being multiplied by negative 5y to the third. So here the 7y, or the 3y to the 7th is not going to change. Negative 5y to the third times 4y to the 6th. Well, negative 5 times 4 is negative 20. Y to the third times y to the 6th is y to the 9th. Good. Now we have the negative 5y to the third times 2y to the 4th. Negative 5 times negative 2. Negative 10. Y to the 7th. 3 plus 4 makes 7. And then we have minus 7y to the 9th. Are we done? No, we're not. 3y to the 7th can be combined with negative 10y to the 7th, which makes negative 7y to the 7th. Negative 20y to the 9th and negative 7y to the 9th makes negative 27. Yep. Y to the 9th. You got negative 20 and another negative 7 makes negative 27. So now that we have these skills, what are some things we might use them for? Now I'm going to admit, because I know at least one of you will ask, where in the real world would we do a problem like this? The answer is, in construction there are some examples, in engineering there are some examples. On what most of you are going to school for, not much. There are some business formulas if you get into economic supply and demand. Like into macroeconomics, you start getting supply curve shifts and demand curve shifts. There are some applications of it. But there's so much theory behind those applications to understand them that we're not going to use them in here. We're just going to use simple geometric applications, which I understand for many of you are not very practical outside this class, are not really useful. But it's a way of getting used to working with the variables so you do run into other formulas that will be in your field of study. Like I said, the economic formulas, supply shifts, demand shifts, price increases, and stuff like that. They'll go through these types of formulas. For our purposes, like I said, I'm going to stick to simple geometric applications because then I don't have to explain a whole lot of theory to understand what the application is.
Does theory go with business math? Do you get into that?
A little bit of theory, but like accounting principles and stuff like that gets more into business theory. If you have taken economics class, you'll get a lot of that. So we might have, let's say we have a rectangle here. Pretend that looks like a rectangle. And let's say the width is 2x squared minus 7x. And the length is 5x to the third plus 2x. Find an expression for the perimeter. So remember, perimeter is 2 times the length plus 2 times the width. So 2 times, what is the length here? 5x to the third plus 2x. Plus 2 times, what's the width? 2x squared minus 7x. But we need to simplify this. We're not just going to leave it like that. We see this first parentheses here. Why am I dealing with this parentheses first instead of this one? Because parentheses, all parentheses happen at the same level. There's the same level of priority. When there's more than one thing at the same level, we work left to right. So we're going to do this parentheses first. Is there anything to do inside there? No, there's not. So anything needs to be done to that set of parentheses. Yes, there is. 2 times 5x to the third is 10x to the third. Good. 2 times 2x, 4x. So it's a positive 4x. I'm going to put plus 4x. Next set of parentheses. Anything to do inside that set? No. Anything to do to that set? You bet. Times 2. 2 times 2x squared is 4x squared. Now that's positive, so I'm going to put plus there, so it's linked together. And 2 times negative 7x? Negative 14x. Are we all done? No. Anything to combine with the 10x to the third? No. Anything to combine with the 4x squared? No. How about with the 4x? Yes, 4x and negative 14x make negative 10x. We might have something like this. Find the area. And the area is equal to length times width. Now in this case, it's easier to flip it and do width times length. Can anybody tell me why? It's easier to have the one-digit number in front. This would be 8x times 3x squared minus 7. So then we do 8x times 3x squared. 8 times 3 is 24x to the third.
Right.
X times x squared is x to the third. 8x times negative 7. Negative 56x. There's our expression for our area. So we're given a box here, and we're told that this is 2x, 5x plus 7, and 4x. We're asked to find an expression for the volume. Well, volume is length times width times height. We've got 2x times 4x times 5x plus 7. Now you might be looking at that saying, well, he didn't do that length times width times height. He changed the order. Of course I did. Why would I change the order and put them in the order I did? So I can multiply these two first. Those are a little simpler to multiply. 2x times 4x is simply 8x squared. Good. So I changed the order to put those two first so I could do the easy multiplication first. And now all I have to do, 8x squared times 5x is 40x to the third, and 8x squared times 7, x squared, yeah. That's a positive 56, we're going to put a plus in there. So there's an expression for the volume of that box. Questions? Okay, it's a little early, but let's take our break a little early. We'll come back at 9:25. We'll start our second half.